Hi, I'm Mark Wilson, the Engineering Heretic, and today we're going to look at starting holes on an angle in steel and other metals and what have you. At the moment, I'll just zoom back a little bit. This particular machine, it's just a standard drill press, a wall down drill, nothing fancy. It's got a self-locking chuck on the thing, so it's quite long and rather skinny looking spindle on this thing. So if I try and drill a hole on that particular angle there, I've got a center punch in here just where I want to start this. If I try and drill a hole on here with my irregular drill, I want to get a 10mm hole through this. If I try and drill that there, of course, it's going to just veer off. It's not going to do anything. It won't start. It'll be terrible. So what I would like to do is find a way of getting something locked into there that will actually hold the drill in place whilst I drill it. Now, one of the counterbores I've made, it actually has a diameter here, which is basically a bearing which holds things central whilst you face here. And on castings and what have you, quite often we'll actually use a counterbore to spot face a hole rather than mill it. So if you're doing a casting and you've got a caster and you want a bolt to go through, we can use a counterbore just to spot face the hole. And it will go in, lock into the hole that's already there, and no matter what, it'll cut a square face. So a counterbore, if I could get that in there, started, would do a really good job. But that's not going to get me going because that takes a 6.5mm pilot there. So what we need is some sort of an alternative here that will basically counterbore a hole and hold it in place, something with a very small tip on the thing. And we have a center drill. Now a center drill is in effect a counterbore with a pilot on the front of it, and there's no relief in that little area there. There's no relief on that. So if I can get that in, it will start, and then this will hold it in position, and then it will basically counterbore out the taper of a normal center drill. But this center drill here is probably a little bit too big, and I've just got a center punched hole here. And what I need to do is get a smaller center punch. So there's a few other ways of doing this. I've seen people put end mills and slot drills into drilling machines, but this is a very long, skinny spindle, and it's not really going to work trying to get an end mill and face a spot, particularly with this long, skinny, self-locking chuck. It's just not going to work. So we're going to use a center drill. Now to start this, I'm going to start with a number 1 center drill because that is the smallest tip I've got here. And also, if I can get this out to a 4.5mm hole with a number 2 center drill, that's slightly more than 4.5mm. I can start using my 4.5mm counterbore that I made the other day, get that in there, spot face it with that, then go out to a 6.5 and spot face it with that. And this one here is 11. I want a 10mm drill, and that will give me the spot face to be able to use my 10mm drill and go all the way through. So we're going to put in a number 1 center drill, and we'll turn that on. Now, center drills require, because they're a bearing area on the front of it here, they always require a little bit of oil. I normally just put a little dab of oil somewhere, and just cutting oil here, and I just put a little bit of a dab on the drill itself just to start this. Now we'll come down here and we're going to get our center drill, and we're just going to drill into that center punch hole there. And of course that goes in no problem at all. There's no side load on this at all because it's such a small drill. it located in the centre punch, no problem at all. And I'm going to run my centre drill down until it basically spot faces on an angle, of course, something that I can start my next centre drill. So now I have my first centre drill hole. Now I can use my number 2 centre drill. My number 2 centre drill, and coming with my number 2 centre drill. Of course, that starts no problem at all in the number 1 position there. And we will just a little bit more oil on this, a little bit of a tad of oil on it, and off we go again. And now I have another spot face slightly bigger, and of course I'll go down a little bit more, just enough so that I can get my 4.5mm drill in. That should do it there. Now, of course, I have something that will take, because this is slightly bigger than a 4.5, this number 2. So we're going to put in a 4.5mm drilled hole, and that's, of course, is going to start in there no problem at all. Okay, now I have a 4.5mm drill in there. I can now use my counterbore. My counterbore, that will go and latch in there, and now I can spot face this out to basically an 8mm. I'll have to slow this machine down a little bit, so it's getting a little bit too quick for this. Now, the front of this little counterbore is basically a bearing, so we need a little bit of oil on this. And we'll run that down there. And of course that starts no problem at all. Because the counterbore holds that central, there's no side load on this chuck at all. So now we've spot faced a section there, and now what I need to do is go out to a 6.5mm drill. And I can run that down. And of course that's going to be no problem at all drilling there because it's got a flat face to start on. Now, I think I want to pile it right the way through here, so I'm just going to carry on and go all the way through here. That's the trouble with self-locking chucks. Right, that's all the way through. Now I can get my 6mm counterbore for a 6mm cap screw, and that's an 11mm OD. Put that one in, and I can spot face that. Once again, I'll need a little more oil. And spot face that. Now I've got something that my 10mm drill will go all the way through, no problems at all. And there we have it, a 10mm hole all the way through steel on around about a 30-degree angle. And I'm Mark Wilson, and thanks for watching.